S6.
So, good afternoon, members. Can you
S6.
unmute and talk to me, all of you? Can we get me?
Yes, we can get you.
So get your pens, your books. We're going to start. Okay. Okay.
So what?
Maybe you can use this time to ask some questions before you can start, where you find some problems. So good afternoon, members. Now we're going to start with the photographic interpretation. And those are the questions we're going to look at. Hope you can see those questions. So we're going to look at different questions and we're going to look at different photographs and how to approach them. We're going to look at all those photographs in case they are brought. And by doing so, you'll be able to answer questions regarding photographic interpretation. So we're going to start by looking at question number 1, and that is drawing a landscape sketch. Drawing a landscape sketch of the area shown on the photograph. So there are 2 ways of drawing this. One, if the photo can fit on your answer sheet, you can just trace it, then you put whatever you want. But if it cannot fit, you first look at the shape. You first look at the shape of the photograph. Then you know if it is a rectangle, then you draw a rectangle. If it is a square, you draw a square. Then you begin by drawing the skyline. After the skyline, then you put the physical features and relief features and the land use activities. So we're going to look at this photo. We're going to begin by looking at that photo and how it can be portrayed. And how it can be portrayed. So, now, when you're told to draw a landscape sketch, I don't know whether you can see here. For example, for that particular one, so for this particular one, you can draw, it's a rectangle, so you draw a rectangle, but you use a ruler. So you divide the photo. Can you see that? So you divide the photo, you divide this photo you're seeing, you divide the photo into 4 lines. You divide into 4 divisions. The foreground, the middle ground, you measure the photo and divide it to 3 times to get the equal parts. So now you draw these features where they belong, but you can begin by drawing a skyline. You can begin by drawing a, let me first see, let me first test if you're seeing and if you're hearing. Joel, can you hear me? Joel, unmute and tell me if you're hearing. Are you hearing me? People unmute and tell me. I want to know whether you're hearing and whether you're seeing the board. You're hearing? Is everything clear? Okay, thank you. So You begin by drawing the skyline. If they are seeing here. Let's see. You need to sign photo. Can use the other or this one, but share the photos somewhere. Yeah. So, so they need the photos. Go to the next photo. So the question is this. The number one is there, draw a landscape sketch of the area shown on the photograph, on its background name, relief features, vegetation types, and land use types. So in case you're given such a feature, such a question, okay, in case you're given such a question, you begin by drawing that shape because it is now a rectangle. So from that, you draw a skyline. Draw a skyline, that form. Then, of course, somewhere here I have a line. Then we have some hills here like that. Then another line touching there like that. So in case they want to put relief features like they are shown here, on each back and name relief features, automatically this is an upland. That's an upland. Of course, where there is an upland, we have steep slopes. We have steep slopes. So those are steep slopes. Then from steep slopes, around here I have gentle slopes. And then from that, you look for land use types. You look for land use types. If you look critically on that photograph, photograph, you have something like that. And of course, that is the road transport. Then from there, we have some trees around here. You mark them as trees. And of course, they're associated with forestry as land use type. Then somewhere here, of course, you have crop cultivation. You have crop cultivation here. That is basically tea. So when they ask you to draw a landscape sketch, when they tell you to draw a landscape sketch on its back and name the land use types. We got the next diagram. Let me talk when I'm facing. Okay, then. So, when you're drawing, I told you you begin by drawing the shape of the diagram. Then from the shape, now you mark, if they say relief features, you begin by marking. Now where we have a hill, automatically that's an upland. Then from the upland, automatically you have steep slopes. Then from steep slopes, automatically you have gentle slopes. Now, the land use types, where there is a road, you put road transport. Where there are trees, you put forestry. If there was a house, a smoker house like that, you can put that as settlement. Then you also look at the vegetation types. Of course, you can have grass, you can have tall grass, like that. Of course, you have trees. Sometimes you can also have shrubs if they are there, but don't put there your savanna vegetation. So that's what we do now. If they ask for landscape sketch showing physiographic regions, if they ask for physiographic regions, don't put these ones. If they are asking for physiographic regions, you put upland region, then you put steeply sloping region, then you put gently sloping region, and then you put maybe low-lying, if it is there. So the first question is always about drawing a landscape sketch. Let me give you another example. Yes. Take the second one. Second photograph. Let's go. So they can tell you to draw that one. So they can ask you to draw a landscape sketch on it, mark and name. Sure, let's mark and name physiographic regions. Sorry. Physiographic regions. If they tell you to draw on it, mark and name physiographic regions, this is what we're going to do. So that's the diagram. So you look at the shape of the photograph. Is it a square? Is it a rectangle? But now for this case, it is a square. So you draw square like that. I told you begin by drawing a skyline. So if you look at that, the skyline is kind of like this. Then there's another hill which starts from there, somehow like that. So if they say on it back and name physiographic regions. So let's back and name physiographic smaller. Let's back and name physiographic regions. Of course, we have a water body which behaves like this. And you have a tree here. So when they say physiographic region, of course, this is an upland region. This is a steeply sloping region. Because here we have a basin region. And of course, we have trees. We have trees here. We have trees. And of course, now, so you have upland region, steeply sloping region, basin region. When they ask for land use activities, you can put here forestry, where I have trees. If there was a telephone mast, for example, you'd put there telecommunication. So I'm going to draw for you one photo now. Like that. Huh? So it's like that. Now I'm going to draw for you one photo. They can give you a photo like this. When it has a highland there like that. Maybe there is a road here. Maybe there is settlement here like this. When there is a forest like this. Maybe there is a telephone mast like that. And maybe there are crops like that. Now, if they tell you to draw this, to draw a landscape sketch of the area shown on the photograph, we need to mark and name physiographic regions, okay? When they ask for physiographic regions, you put this one as upland region. If they're asking for regions, if they're asking for features, you put upland. So region, you put this. Feature, you put this. For example, if they ask, you can say steeply sloping region. If they ask for feature, just say steep slopes. So this is a region. This is a slope. Then of course this is now a gently sloping region. But if it is a feature, you say steep slopes. Then maybe here I have low lying region. So they can say on this mark, if they ask for relief regions, this is what we put. They ask for features, you just say upland, steep slopes. You say gentle slopes. And you say lowlands. That's the difference. So that's the first question. The second question they can ask you to describe the relief. Describe the relief of the area shown on the photograph. Describe the relief of the area shown on the photograph. So if they ask for that question, there are two ways of doing it. You can start with a ground, then you give the relief, or you can start with the relief, then you talk to you give the ground. For example, now you have to know the different division of this photograph. Because this is foreground, middle ground. So foreground, then maybe this part middle ground, then this is background. So now in the background, you have this upland. So you can just say, you can start with the ground by saying the background is hilly. Are you together? So you've mentioned the ground, but don't write in short form. The background is hilly, or you can say there is a hill in the background. So it's up to you to do what you want. You can say the background is hilly, or there is a hill in the background. Then you can also say the hilly background has steep slopes. So we have this hilly background and it has steep slopes. Then after that, what about the middle ground? So you can say the middle ground is gently sloping. Then you can say the foreground is low lying. So that's how we describe relief. Measure the ground, what is there. I think that is okay now. So you measure the ground, the background, there's an up, you can start with the relief, then you can say there's an upland in the background. The hilly background has steep slopes. There's a gentle slope in the middle ground. There is a lowland in the foreground, so it depends on what you want to write. I guess we're there now. So, hope you're getting me. Hope you're getting me. So let's continue. Now we're going to look at the relationships. So the other question is about the relationships. They can say, describe the relationship between relief and land use types. Describe the relationship between relief and land use types. Okay? Oh, I'm very speedy. It's okay. Describe the relationship. I have to cover out of things, so you'll go back and watch the video. Describe the relationship between the relief and land use types. So the best formula is start with the land use type. Land use type. Give plus a relationship plus relief plus ground plus reason. So you give a land use, for example, if you look at this hilltop, you say telecommunication is now found is the relationship. Telecommunication is found. So this is the relationship. Where on the which relief? On the upland. On the upland. Which part of the photograph? In the background. Which reason? For easy sending of signals. For easy sending of signals. So what are we looking at? We're looking at, let me write them here. We're looking at land use plus relationship plus relief plus ground plus reason. So you look at land use, relationship, relief, and land use, relationship, relief, ground, and reason. For example, we have this road. So you can say transport. Transport is the land use. Is found. Found is the relationship. On gentle slopes. Now, gentle slope is the relief. In the middle ground. Middle ground is the ground. Why? Because it is easy to construct. So you have to give a complete answer. Land use, relationship, relief, ground, and reason. If you look at these houses, for example, you can say settlement. Settlement is found. Found is the relationship. still on gentle slopes in the middle ground. Why? Because it is very easy to construct houses there. You can talk about forestry. This forestry here is found on the steep slopes in the middle ground, part of the middle ground and part of the background. Why? The reason is to control soil erosion. So if the forests are found, if forestry is found on a gentle slope, then the reason is because of we're doing fertile soils. If forestry is found on a steep slope, the reason is to control soil erosion. So that's how they give the relationship. For example, if you had the crops here and you had terraces, for example, then you say crop cultivation is found on steep slopes in the middle background through use of terraces. So you have to end by giving a reason. Hope I'm clear. Ask.
So, okay. Wakata, Joel Wakata, ask your question. Okay. St. Andrews, Rutome, ask. Unmute and ask.
Yes, good evening, Master. Yes, what we wanted to know, because we are now doing the work, but the questions, we don't have them. Where shall we get the questions?
Okay, now the question we are discussing, you can put it down. The first one is this: describe the relationship between relief and land use types.
Yes.
Describe the relationship between relief and land use types. Are you seeing the question?
I'm seeing, but how shall we share them?
Of course, you can easily go to the YouTube. You'll find them. We are going to send you that. So the first one was describing the relief. I think, have they gotten how to describe the relief?
Yes.
Okay. Then the second one is describing the relationship between relief and
the land use types.
Yes. Have they gotten that?
Yes, sir.
Oh, that's very good. I'm very speedy. Sorry for being speedy, but I want to cover out of things. Maybe they'll go back to the YouTube and watch, okay?
Okay.
Okay, so
thank you,
the next question is explain the problems first.
By
explain
the people
the problems.
living,
it's on the screen.
By the people living in the area, yes.
Yes?
I'm seeing on the screen.
Describe the problems faced by the people living in the area shown in the photograph.
Yes.
Okay. Joel, say something.
No, since I'm seeing and I also see how it's answered, so it is okay. It's only on the side of the questions.
Okay, it's okay. Let me hear from other people who have put up their hands. Okay, say something. Okay, Sharon. Mary, Stacia, say something. Unmute and say something. Yes, Mary, say something. Unmute and ask your question. Your hand was up. Yes. Okay, Sharon. Can I continue? Okay, unmute and I continue. Unmute and I continue. So we're going to look at explain the problems faced by the people living in the area where the photograph was taken from. So, Sharon, unmute. Joel, unmute. Okay, so we're going to look at this and see the problems faced by the people living in that area. So the problems are, now when you're giving the problem, you begin by giving a problem. The formula is, please unmute. Unmute. So the problem is, the problem is, you begin by writing the problem, that's the formula, plus, okay, let me write it here. So you begin by writing a problem plus how it is a problem plus, are you listening? We write a problem plus how it is a problem plus evidence plus ground.
No.
So a problem, how it is a problem plus evidence plus ground. For example, that we have a problem of lands. Don't say there's a problem of, hint on the problem. Don't say there's a problem of this, there's a problem of this. Just say there's land, or you just say landslides. Landslides, that's the problem. So the problem is landslide. How is it a problem? Which leads to destruction of property. Evidence, so this is the problem, this is how, then due to steep slopes in the background. So if given landslides, that's the problem. How is it a problem? Which is destruction of property. Evidence due to steep slopes. Steep slope is the evidence. Ground, background. Are you there? Then you can talk about, now, when you have this kind of photograph, look for problems associated with hidden areas. For example, we have soil erosion. How is it a problem? Which leads to loss of soil fertility. Are you together? Still due to steep slopes in the background. Are you following?
Yes.
Let me see if you're following. It is a must write the background. If you don't refer to the ground, you don't get a mark. So it is a must. Maybe let me first hear from Kongonga High. What are you saying? Unmute and ask your question. Panyango SS, what are you saying? Your hand is up. Panyango SS, ask your question. Unmute, unmute. Yes. Unmute and ask your question. So when you're giving problems, yes? Okay, when you're giving a problem, you have to give us a problem. For example, if you look at this photograph, the problem is, if the problem is landslide, show us how is it a problem. It is to destruction of property and yes? Ask before I continue. Ongia Tobias, what are you saying? Can I continue? Okay, let me continue. So, yes? Can you unmute if you don't have questions? Okay, someone is asking, is it a must to measure the width and length? No, it's not a must, but you have to, when you look at the photograph, because when they are marking, they look at the relative positioning. So the relative positioning, you have to put the feature. If the feature is in background, you put it in the background. If the feature is in the middle ground, you have to put it in the middle ground. That's why we measure and divide that photograph into 3 equal parts. Okay, let's continue. Don't use a pen, use a pencil to draw. Okay, we don't reduce the photograph, but we just draw a shape. If you create clear shape, it will come out. Okay, let's continue. So I say you give a problem. How it is a problem? Give evidence and ground. You give a problem. How it is a problem? Evidence and ground. For example, we have difficult in setting up. Let's first leave this one. You can give another problem. For example, hinders construction of transport and communication lines, which limits movement of goods and services. Reason due to stable slopes where ground. Now, how do we get these problems? Look at the feature in the photograph. We have this highland. It has so many problems associated with it. So you can bring out those problems, but following this order. If there are trees, or if there is a forest, which problems are associated with forests? If there is a lake, which problems are associated with the lake? For example, if you had a lake around here like this, you had a lake around there. Let me try to. Okay, if you had a lake around somewhere here like this, if you had a lake around here, okay? So now you will talk about drowning of people, which lead to death, evidenced by the lake in the foreground. Are you getting? So, am I allowed to trace the photograph? Yes, you can trace it. You can trace it very well. In fact, if it can fit on your paper, trace it and put it on the and then draw it on the answer sheet.
Are you okay now?
Are you okay now because of a computer? So help me on the relationship. Okay, let me repeat on the relationship. You're seeing that photograph. Now, in the background, if you look critically here, there is a telephone mast. Now, on which road feature is it found? So this telephone mast is found on the hill. Are you together? Where is that hill? This hill is in the background, right? Why is it there? Are you together? Why is it there? Because of a certain reason. Why is it there? Because let's look at that one. So if you are to give the relationship between that one, you find that we have crops grown on the hill, and this hill is in the middle ground. The hills in the middle ground and background, and the reason is because of well-drained fertile soils. You're seeing that road moving, winding around the mountain. So the road is found on the gentle slopes, and you give the reason where in the middle ground. Why? Because it is very easy to. Yeah. So let's continue now. First come. So that one is done. Now we're going to look at something else. And that is someone is asking about accounting for the formation of features in the photograph. So I'm going to look at account for the formation of feature, that question there. Account for the formation of features shown in the photograph. We're going to begin by looking at this feature there. So you begin by identifying the feature if you're answering the question. You begin, first wait, I'm going to tell you everything. So you begin by, if they say account for the formation of the feature, you begin by identifying the feature. If you begin by saying account, the feature is formed, the feature was formed, you don't get marks. You say the feature in the photograph is an upland, or it's a hill. Are you getting?
In the background of the photograph.
The feature in the background is a hill. Are we together? Or it is an upland. Or it is a ridge. So you begin by identifying the feature. When you end by identifying the feature, then you identify the process which led to the formation of that feature. So, for example, let's look here.
This one is volcanic.
Okay. So look at this feature on the. So if they say account for the formation of the feature in the background, this feature you're seeing. So you begin by identifying the feature. You say the feature in the background is an upland. So you have to identify it. An upland or a hill. Then identify the process. This feature, this upland, was formed as a result of volcanicity. So you've identified the feature, you've identified the process. Are we together? So then you say, you give us the origin of this volcanicity due to geochemical. Geo means rock chemicals. So the chemicals within the rocks can react. That's why I said due to geo means rock chemicals reacting. Then there's also geophysical. Rocks can be compressed, they can rub against each other, and as a result, that's what we call geophysical. And these are now geochemical, this is now geophysical reactions. And radioactivity decay. So we said the feature in the background is an upland. The feature in the background is an upland. It was formed as a result of volcanicity. Then now when you said due to, you're giving the origin. Due to geochemical, geophysical reactions and radioactivity decay. What do these ones do? These ones generate intense heat. Are you following? Then the heat leads, or you can't see. So they generate intense heat. Now the heat leads to the melting of rocks in the mantle into semi-molten state. I'm going to repeat again. I started by identifying the feature. The feature in the background is an upland or hill. It was found as a result of volcanicity. Which one is the origin of volcanicity? Due to geochemical, geophysical reactions and radioactivity decay. I said geochemical, the rocks within the chemicals within the rocks can react. Geophysical, the rocks can rub against themselves or can get compressed. And as a result, heat is generated. or radioactivity decay. Some minerals like uranium, when they decay, they generate heat. So these ones generate a lot of heat. Which heat? Which heat? Which heat? Look here. Now I'm going to remove this. I'll repeat. So this heat, we have now this.
It's too much to explain the volcanicity only.
I see. So you have this as the core, this as the mantle, this as the crust, and this as the surface. So we're saying that the rocks here experience geochemical, etc. Now they become so hot, and then they lead to the melting of rocks here into porridge form, which we call say molten. When these rocks melt, now after melting, they start boiling like porridge. When they start boiling like porridge, that's what we call the generate convective currents. After melting, they start boiling like porridge, which you say they generate convective currents. And due to differences in pressure between the Earth's interior and the Earth's crust, this material start moving upwards and to be intruded into layers of the Earth's crust. Then later, the industrial forces can expose the rocks to form this upland you are seeing. So I'm summarizing now. I've said to identify the future is an upland. Are we together? Yes. You identify the process, which was formed as a result of volcanicity. You give the origin of that volcanicity due to geochemical, geophysical reactions, and radioactivity decay. What do? They generate intense heat. And this intense heat is the melting of the rocks in the mantle into semi-molten state. Then when the rocks melt into semi-molten state or porridge form, then we have generation of convective kinds. They start boiling like porridge, the way you see porridge boiling. Now, due to the differences in pressure between the Earth's interior and the Earth's crust, we have now that upward movement of magma, which is intruded into layers of the Earth's crust. Later, the industrial forces remove the industrial processes of weathering, erosion, and what? Removes the overlying layers, and the upland comes out like that. So that's that one. Now, we're going to look at another one where, for example, we have rocks which are, where I have rocks that are, okay, let me first get people saying something. Amogu SS, I'm seeing your hand up. You can unmute and say something. Can I continue? Okay, now photographic interpretation comes from different all topics. For example, I don't know whether you've ever seen the stalactite and stalagmites. Those karst landforms, I'm going to show you. Then they can bring, like, for example, block disintegration. We're going to look at different photographs. And after looking at, someone is saying, wait, what's the problem? Send a message if you can't talk and tell me the problem so that I can continue. It's better you send a message, I'll see it. So far we've covered, let me summarize what we've covered on photograph. We've covered drawing. When you're drawing, there are two ways. You can trace if the photograph is small and can fit on your paper. Two, you can just, if it is too big and cannot fit on your paper, just bring out the outline very well. If it's a rectangle, draw a rectangle. If it's a square, draw a square. Then begin by drawing the skyline. Indicate if they want relief features, don't know how many they want. Don't put don't put one feature. If there are hills, there are steep slopes. Then gentle slopes. If they're asking about relief regions, you say upland region, steeply sloping region, low-lying region, etc. Then when they ask for a relationship, I said, you begin by mentioning the land use. Settlement is found. Found is the relationship on the gentle slope in the background. Then after that, we got the problems. Problem, you can start with the ground problem. The background is hilly. The hilly background has steep slope. The hilly background has steep slopes. Then when it comes to formation, you begin by identifying features. Now, you're not going to be seeing me, but we're going to talk about different features now, the ones that are shared. Now, like that feature, if you look at it, they tell you to account for its formation. Of course, it's an upland. And just when it was at first formed inside by intrusive volcanicity, then it was exposed by the inundation forces to appear. That's why you identify like we've done. Then we have this other one. We have this other one. We have that other one. Hope you're seeing it. So they can begin by telling you to draw a landscape sketch on it, mark and name 2 physiographic regions. Of course, this one can be, at first it was an upland, then it was broken. Then this is now a low-lying or gentle sloping region. Now, if they ask you to account for the formation of that feature, still, you have to give 2 processes. The first process is volcanicity, which led to the intrusion of that material inside. Then you also talk about the inundational forces, which expose these rocks on Earth's surface. Then you talk about block disintegration, whereby the rocks were exposed to alternate heating. They were heated during day. The rocks were homogeneous. They had homogeneous minerals. So they were heated during day, where they expanded. Then at night, they contracted. Heated during day, they expanded. Now repeated expansion and contraction into the breaking of rocks into various blocks. So when you're doing that, you have to talk about 3 things. One, you identify the feature. The feature can be calcium copies or granite tores. How was it formed? It was formed as a result of volcanicity. Give the origin. Tell us how the material was intruded into the Earth. In fact, they can put their 8 marks. Now, to get those 8 marks, you have to work very hard. So you talk about how volcanicity led to its intrusion into layers of the Earth's crust. Then after that, you tell us how the inundational process removed the overlying layers to expose it. Then after its exposure, you have to go ahead and tell us that it was exposed to repeated heating and contraction. And because they were homogeneous rocks, they developed blocks, different blocks. I don't know whether I've answered your question. Then we go to another one, which is this one. Hope you're seeing it. Are you seeing it? Are you seeing that? So they can tell you to draw on it, draw a landscape sketch on it, mark and name physiographic regions. If they say physiographic regions, of course we have an upland region. We have we have a plateau in the background. Then we have a gentle slope in the foreground. Now you say gently sloping in the foreground, upland region, then plateau region. If they ask for relief features, you can talk about a crater, you can talk about steep slopes, you can talk about gentle slopes, and you can talk about highlands in the background. How was it formed? Of course, you begin by, these features are in Uganda. If you go to Western Uganda, those features are there. So how was it formed? These features are in Uganda, sir. So how was it formed? You identify the feature in the photograph is a crater. Are we together? It's a crater. It was formed as a result of volcanicity. Give us the origin of volcanicity. Are we together? Then from there, explain how a volcanic mountain was formed when material was vertically erupted through the vent and piled around the vent. Then the lava solidified within the vent. Now the next eruption, what we call the subsequent eruption, formed when the vent was blocked. So it violently blew off the top of a volcanic mountain to form that crater. Then you can give us examples if you know. So that's now a crater. We're talking about how to account for the formation. Then, yes. Then they can also bring that. Now, if you look at that, don't commit yourself, but that's now what you call a basalt dome. But now don't commit yourself. Just say the feature in the background is a ridge. Now, most of the hilly areas use volcanicity. Don't talk about faulting. Most of the hilly areas use volcanicity to explain them. But now this one, if you look at it, it has gently sloping side. So you're going to talk about the lava which came out and was able to spread for some distance before solidifying. So he had the silent eruption of basic lava which flew for a long distance before solidifying. That's why that eruption which spread for a long time led to the formation of those gently sloping sides. So we can also look at this now. If they tell you to do that, a landscape sketch on it, mark and name, relief features. Of course, you have a ridge, we have a conical hill, we have steep slopes, we have a gentle slopes, then we have a lowland. Then when they say land use types, of course, there's forestry, there's settlement, like that. Then we go to this one. Now that one is a delta. They rarely bring them, but you never know. Hope you've covered rivers. You need to know the formation of deltas, but I'm not going to go into details of that. Then we have that one.
Waterfall.
That's a waterfall. So you identify, you say the feature. Now they can tell you to draw a landscape sketch. Are you seeing this, the small skyline? You put it there. So you say a landscape sketch showing. Now we have a waterfall. We have a cliff. They can ask for a plunge pool. They can ask for a plunge pool. Then after that, they can say, account for the formation of waterfall. Now, when they say account for the formation of waterfall, please give all the causes for the formation of waterfalls. Now, the causes for the formation of waterfalls, we have a waterfall can be formed where a river flows over the edge of a cliff. A waterfall can be formed where the river flows over the edge of a cliff. A waterfall can be formed where a river flows over hard resistant dike. A waterfall can be formed where a river flows over hard resistant dike. A waterfall can also be formed where we have a band of hard rocks overlying soft rocks. So when the river is flowing on top of hard rocks and finds the hard rocks end and finds hard rocks, it will dig them to form a waterfall. A waterfall can also be formed where you have a river flowing from a hanging valley, where you have a river flowing from a hanging valley into a U-shaped valley or a glacial trough. So you know so many causes of waterfalls, you have to give them. Don't give one, because they can put there 8 marks. When you give 1 point, you get 1. Full stop. Now, when they ask for importance of the feature, please give the positive and the negative. So you have also that feature. They can ask you to draw a landscape sketch. So now you know how to do a landscape sketch. Then they can ask for a relationship between relief and drainage, relief and communication, etc. So I hope now, first ask question. Now, before you ask question, you have aerial photographs. Now, aerial photographs, when we are interpreting aerial photographs, we don't mention ground. For aerial photographs, we mention Sorry. Moment. So for aerial photographs, we mention we mention top, center, bottom. For aerial photograph, after drawing the photograph, you mention top, center, bottom. Don't mention background, don't mention foreground, no. So when you are referring to it, and when they tell you to draw an aerial photograph, usually they tell you to trace. If the school cannot afford tracing papers, you just put that photo, put it on top of your answer sheet, trace it. And when you've drawn it, say a traced map. Don't say a traced photograph. Say a traced map. Are you following? You say a traced map. Don't say a traced. Don't say a traced photograph. No. Aerial photographs are looked at as the maps. So you say a traced map showing this and this and that. Then how do we interpret aerial photographs? This is how we interpret aerial photographs. One, we look at the smoothness. If you see that area is dark and smooth, that's a water body. If you see the area very rough and dark, that's a forest. Let me repeat. If there's a portion on the photograph that is rough and dark, that's a forest. If there's a portion on the photograph that is dark and smooth, that's a water body. If you have lines that are straight, any feature with the straight sides or straight lines, those are communication lines. Where you have a kind of a line with a zigzag, that can be a river. Where you have straight lines with the big buildings, those can be industries or warehouses. Where you have straight lines with the small building, that can be settlement. Okay, let me first look at these people who are asking, then I continue. So we are not seeing the work. No, I'm not giving, I was showing you the photograph, then you're going to see the work afterwards. So don't worry, you're going to see that very soon. So now, give me 2 minutes. Okay, let's continue.
Next year, what?
Now, am I allowed to draw lines in a landscape scale? You know what you've drawn, you're not supposed to draw. Make sure you draw. So what you're supposed to draw, you're supposed to draw the lines when you're interpreting, such that the lines you draw help you to know where you're going to put the features. Because when they are marked, they are very strict on where the photographs are supposed to be found. Okay? Okay, now we continue. Okay, so after that, we're going to look at now the aerial photographs. The aerial photographs, you don't say, the aerial photographs, you don't say background, foreground.
You'll answer the questions later. First, give us the package. Don't you know anything? I can't check.
Please unmute, we are not hearing.
Well, like,
Unmute people.
No, getting
feedback. Okay. So now we're done with photographs. We're going to look at some bit of maps. So, how do we reduce the maps? How do we draw? How do we reduce the maps? Now, they can tell you to reduce your map by. That's what I was talking about. In case it is broad, please. In case that one is broad, those are landforms resulting from chemical weathering. Seeing it? Those are landforms resulting from. Can you people mute? I'm getting feedback. So those are landforms resulting from chemical weathering. Now they are very easy to do. Now are you seeing those white things which look like which are attached to the roof of the cave? That's what we call stalactite. Are you seeing the ones that are down? That's what we call stalagmite. Are you seeing one which is connecting to the floor to the top? That's called a pillar. Now, the easiest way, if you want to know how to explain this, talk about the process of carbonation. Are you together? Talk about how rainwater mixes with the carbon dioxide of the atmosphere to create a weak carbonic acid. When this weak carbonic acid gets into rocks containing calcium carbonate, it dissolves them. And when it's dissolved, it starts dripping. And when it solidifies on the roof of the cave, it is called a stalactite. When it drips and solidifies on the floor of the cave, it is called stalagmite. When it drips and the stalactite joins with the stalagmite, it forms a pillar. So you have to prepare, you never know what can come. Now someone is saying how to approach the region. Now if they say in which region was this photograph taken from, be specific. If it's a waterfall, don't say, like for example, come from Captura, Falls. Just say CP Falls in Captura. The reason is because the fall in the photograph is also found there. But if you say Captura, you'll not get a mark. For example, these ones are found in Nyakasula. So you can just say Nyakasula, stalagmites, and stalactites. If it's a mountain, you can say Moroto Mountain or Kadam. Or you can say any mountain and the district. The reason the feature in the photograph is also found there. Okay, you can send your questions and I'll be answering them as I teach. So, how do you describe relief on the photograph? But I talked about that. Just mention the ground and relief. I hope you're enjoying. What? So please, approaches when answering all papers. No, we're talking about job one now. So we're about to do photographic adaptation. Now we're going to look at map work. I can't teach everything in one day. So let me teach what I can and it's what to do. So let's look at some bit of map work. Then I go to how to write SC questions because that's where I have issues. Okay. So we're going to, I wanted to look at that photograph. In case you're told to draw a landscape sketch, I think now you can draw. You're seeing the background, you're seeing the forestry on top, you're seeing a telephone mast. Hope you're seeing that telephone mast there. Are you seeing it?
Yes.
So that is for telecommunication. Then you're seeing the crops there. We have crop cultivation. You're seeing the transport route. So if they tell you to put relief regions, upland region, steeply sloping region, gently sloping, low-lying, like that. So let's go to now map work. So now you must know those ones. You must know those ones if you're to pass geography. Hope you're seeing them. If you're seeing them, send me a message. You have to know whatever you're seeing on the screen. Gradient, area, maybe you can send me some messages on what you don't know and we talk about it. You can send a message and we talk about what you don't know. Out of all that,
intervisibility.
You can talk. You've said intervisibility.
Intervisibility.
Okay, I've noted that one. Which other one? Someone is asking about an annotated sketch. An annotated sketch is that sketch with local names. If you're drawing a cross-section, you put local names. If you're drawing a sketch map of the area where you carried out your field work, don't just say hill. Say Kabong Hill, Kangole Hill, Amagu Hill, Panyango gentle slope, like that. Kangunga swamp, something like that. Now, so we're going to look at how to reduce. Now, when they tell you to reduce by percentage, for example, we have that as our map. You have that as our map, and they tell you to reduce it by percentage. You get your ruler, you measure. Are you hearing? You measure the length and the width. Now, if they have told you to reduce by, say, 2 times, just divide. For example, after measuring the horizontal part or the width and getting like 30, you divide by 2. That's what you draw, 15 centimeters. Then you measure the length. After measuring the length, divide by 2, you get 15. No, like if it is 30, you divide by 2, you get 15. So you draw that box. After drawing that box, now we have to put those thick lines. Hope you're seeing them, those thick lines. So you have that one which is marked 70. Hope you're seeing it. Are you seeing 70? That line marked 70. Now to mark it, you begin from the first easting, you measure, you reduce by 2, you get that. So after that, now when they say on it mark and name relief features, we're going to look at how relief features look like when I put on the screen. We're going to look at how drainage features look like. We're going to look at how everything is needed looks like. So reducing, now when they tell you to reduce by percentage, just get, if for example, I've told you to reduce by 50%, just get 50, divide by the distance you've gotten the length times 100. No, 50 over 100 times the distance. You've gotten the width and length. What you get is what you measure. Hope that one is very clear. Maybe I'll get a day for map work because I wanted so much to go to section B because I know that's where you have problems. How do you see? Advise me. Shall get a day for section B, but maybe I can teach you how they describe relief. Hope you can see the board. So how do they describe relief? So relief, we have hills. We have hills. Now other hills we have, where I have when it is almost like a circle like that. And that's a conical hill. That's a conical hill, and it looks like that. So when you're describing, you say there is a conical hill around this place in this direction. If you look at that map, you have conical hills. Then we have also one which is oval, kind of like that. Now that's a flatty, topty hill. So if you see that one anywhere on the map, you say there's a flat topped hill around this direction, around this place in this direction. Then you also have this one. So that one is a knoll. So as you say a contour like this, you say there is a knoll around this place in this direction. Once you have this one, where contours do this, and they move along this place like that, that's a ridge. So that's a ridge. Where you have these ones, contours bending like that. Hope you're seeing. Let me do it again. So where you have these ones, contours behaving like this, those are spurs. Are you together? So you say there are spurs around this place in this direction. So these are hills now. After hills, we go to slopes. Slopes. Now under slopes, we have steep slopes. Now steep slopes is where you have contours so closely packed, so close to each other. It can be in a circular form, or when it is like this, it is just a steep slope like this. If it is like this, it can be like this, either side steep. Then we have gentle slopes. Gentle slopes. Gentle slopes is where I have that gap like that. Or it can be a circle, a hill, but with the gentle slopes. So those are gentle slopes. Then where contours are far away apart from each other like that, or like this, when the circle is big, that one is now a plateau. Are you together? Then from there, we also have, we can have a map like this. Okay, to be done. Okay, we can have a map like this. Can I erase? Can I remove? So you can also have a map like this. Can I remove this? Can I remove this? Someone answer me. Can I remove this now? Okay. So you can have a photo drawn like this. Let me first remove this one, the first one. Now, where you have a map like this, and it has maybe a lake like this. And they tell you to draw. Of course, this is now a lake. And this is now a basin. If you have, for example, papaya swamp here, of course, now this papaya swamp is found in, now this is now a roady valley. And now this is papyrus. Okay, so this one now becomes now. So this one now is a papyrus. Now there's a difference between papyrus swamp and papyrus vegetation. There's a difference between papyrus swamp and papyrus vegetation. Papyrus swamp is drainage. And papyrus vegetation is vegetation. So Then we also have papyrus vegetation. Now, where you have seasonal swamps, automatically that is a low land. They have seasonal swamps, that's a low land. Now, after knowing these relative features, you can be able to describe relationship on the map. For example, if you have this lake, let's look at this lake. For example, I think that lake Nachivari. Yes. So now, if you're to describe that, if you look at that lake, for example, I'm going to describe relationships now. Hope all of you are seeing. Now, that lake, you just say Lake Nachivari is found in a basin in this direction, full stop. So if they say, okay, you can say, describe relationship, write it for me, this question. Describe relationship between relief and drainage. Write it somewhere. Describe relationship between relief and the drainage. Are we there? Describe relationship between relief and drainage. So describe relationship between relief and drainage. So you see, that Lake Nachivari occupies a basin. Occupies a basin. So just say, lake, don't say, lakes occupy, be specific, just say, Lake Nachivari occupies a basin in the northwestern corner. Then what about the papyrus swamps? What about the papyrus swamps? Now, wherever you see a papyrus swamp, that's a Brody Valley. So are you seeing the papyrus swamps? Are you seeing the papyrus swamps? Yes. So the papyrus swamps around, or the papyrus swamp northwest of Lake Nachivari are found in a Brody Valley. Are you seeing? Can someone send me a message to tell me whether you're here, you're getting me? Then what about the, are you seeing the seasonal swamps? Are you seeing the seasonal swamps? The seasonal swamps? The seasonal swamps is that blue water which is dotted like this. Let's go back. Okay, there. Are you seeing that blue? That's enough. Are you seeing those dotted things which are blue? That's now our seasonal swamps. So you say seasonal swamps around this place are found on a lowland. Are you following? You send me a message if you're following. Then we look at rivers. Yeah. So are you seeing that river there? Are you seeing that river with the blue water? That one. Yes. Again. Okay, first wait. There. So are you seeing that river there? Are you seeing that blue line? That's a river. Are we together? Can someone be responding at least? Look at the contour through which it is flowing. The contour is like this. The contour is U-shaped like this. The contour is like this. Are you seeing? So the river is doing like this. So you say rivers flow through the broad valleys. If the river was like this shape, then you say rivers flow through, you give us the name of a river. You say River Kagango flows through broad valleys. If it was this shape, you would say River Kagango flow through narrow valley. Now, if you have a river like this, and down here is where it ends, there is a seasonal swamp. Then you say river and so floods in a lowland. That's the relationship between relief and drainage. Now, relief and vegetation, you go to the key of the map. You still have forests, scrub, bamboo, plantation. Now, when you reach there, we don't have it. So when you look at that map, you just look at the relief feature. You see the contours. For example, if you look at the contour, if you look at those contours, I'm seeing different types of vegetation. We have this kind of vegetation here. We have this kind of vegetation like this. Okay. If, for example, if we have this, are you together? And there we have this kind of vegetation. Then you say scrub is found on conical hills. If you have a gentle slope like this, and on that gentle slope, we have a certain kind of woodland like that. Then you say woodland vegetation is found on, so it's a matter of knowing the vegetation type and which type of relief is found. So now we can talk about some calculations. So if they gave you a map like this, and this map has these lines like that, and maybe there is this lake, and they ask you to calculate the area in square kilometer covered by this lake. So you begin by writing the formula. Now the formula is, that's right, the formula is full squares plus half squares divided by 2. So you come here, when you're counting, learn to count like this. So now you begin by counting the full squares. So you say 1, 2, 3, 4, 5, 6. So you write 6 plus. Now they have 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 divided by 2. So you get 6 plus 4, it will be 10, but don't end there. You say, but now these boxes are called grid squares. So you say 1 grid square is equal to 1 kilometer squared. Therefore, 10 grid squares equal to 10 times 1 kilometer squared. Then you write the area is equal to 10 square kilometer. That's how they deal with the area. For example, we have this map. They can tell you to calculate that area covered by Lake Nachi Valley in square kilometer. They can say between this easting and this, like that. So if they ask you to do that, that's what you do. They can also bring this. They can also bring this photograph, that, and they tell you to calculate the area covered by that forest. That's what you do. Then we also have another calculation. And that calculation is about after drawing a cross section. For example, if you draw your cross section like this, let's say started from 1,500, 1,600, 1,700, 1,800, 1,900. And the same thing up to here. So, and you drew your really feature like this, and you shaded like that, and you put here, you've measured this distance and say original distance is 5 kilometers, and you say here height in feet, and you've put your title. Now, they tell you to calculate one, the vertical exaggeration. They tell you to calculate two, the amplitude.
The vertical interval, vertical exaggeration.
Then they tell you to calculate three, gradient of the cross section. So what you do, can you listen? What you do, now to calculate the vertical exaggeration, the formula is vertical scale over horizontal scale. To calculate the vertical exaggeration, the formula is vertical scale over horizontal scale. Yes, so how do we get the vertical scale? We get the vertical scale from here, what you are adding here. For example, the vertical scale can be 1 centimeter, we use 1 centimeter, and it might be representing either they can be feet or meters, depending on the map. For example, 1 centimeter is representing 100 feet. So now your vertical scale now will be 1 centimeter represents 100 feet over. Now the horizontal scale is what is always on the map, 150,000. So over 1 to 50,000. Then you say vertical exaggeration is equal to 1, 2. Now, if these are in feet, if the units are in feet, you multiply by 30.
Only slow.
If the units are in meters, you multiply by 100. Let me repeat. If they, to convert, because now this is 1 centimeter represents 100 feet. This is 1, 2. Now these ones, the units are the same. These ones, the units are different, but we want to convert them to centimeters. So to convert these centimeters to meters, you get this 100 feet times 30. But if your map was in meters, you multiply by 100. So divide by 1 to 50,000. Then from there, of course, you'll have 1 to 3,000 over 1 to 50,000. Then this is ratio scale or fractional scale. So you can change it and say it is the same as 1 to divide by 1 to, like that. So you change the reciprocal, you get this times this over that. So you cross this, you cross that. Then 50 divided by 50 divided by 50 divided by. So you get the answer there. Let's first get the answer. What's the answer? Give me the answer very fast. Can I have the answer? 50 divided by 3. It is, the answer is 1.666 times. So that's the vertical. So the units you put times. So when they try to calculate the amplitude, we look at the highest contour when you are drawing your thing here. So the highest contour minus the lowest contour. So what you get is what you put as your answer. Then the gradient is the formula is the vertical rise or amplitude over horizontal equivalent. So the formula for gradient is the formula for gradient. Write the formula for gradient. Write the formula for gradient.
There y squared there.
Write formula for gradient of the cross section.
That's a condition.
I'm very speedy. Okay, write for me the formula for gradient. You say vertical rise or amplitude over horizontal equivalent. So now you get the vertical rise is this one. The amplitude is the difference between the highest contour minus lowest contour. So the difference, let's say our highest between here was 1,500 and our lowest was 1,100. So when you subtract, you get 400. So you say 400, which is now the amplitude over this distance here, 5 kilometers. But now you have to convert this into meters and you have to convert this into meters. So you ask yourself, how many feet are in a meter? You multiply by 0.3. How many kilometers are in you multiply by 1,000? So 400 times 0.3 divided by 5,000. I've said the formula for gradient is amplitude over horizontal equivalent. Amplitude is the distance between the highest contour of which we are plotting here. Then the horizontal distance, we said amplitude over gradient is equal to amplitude over horizontal distance. Are you there? Now, what is the amplitude? Look for the contours you're plotting here. Look for the highest contour minus lowest contour over this distance here, which is the horizontal distance. For example, you know how to get this, use a thread. Let's say these are 5 kilometers. So what do? Get this over horizontal distance. So the amplitude, if the highest was 1,500 and the lowest was 1,100, we shall come here and say 1,500 minus 100 over 5 kilometers. Are you following? Then from there, you get 400 over still 5 kilometers. So these are 400 feet, these are 400 kilometers. Now to convert feet to in 1 foot, that foot has 30 centimeters. So meaning meters are bigger than convert this one. Multiply by 0.3 over 5 times Z. How many meters are in a kilometer? 1,000. So shall get 120. So when you divide, what do you get? Not a fraction. The other fraction, you cross here and you cross here. You can say you can even leave it at that, they mark it. You can leave it at that, they mark it. Okay, we're done with map work. Maybe you shall get another time to look at map work. We're now going to section B. Okay. Write for me that question. Write for me that question. Account for the formation of igneous rocks. Account for the formation of igneous rocks in East Africa. Account for the formation of igneous rocks in East Africa. I'm going to give you a trick of passing this. I'm going to give you a trick of passing this. I'm going to give you a trick of passing this.
Account for the formation of igneous rocks in East
Account for the formation of igneous rocks. So, so you begin by defining. So, igneous rocks. You don't write heading. Say, igneous rocks are fire from the rocks. Fire from the rocks.
May use your calculation.
Are fire formed rocks. Are you together? Are fire formed rocks?
Beautiful girl.
Igneous rocks are fire formed rocks formed as a result. As a result of cooling, solidification, and crystallization of molten rock. Either in the Earth's crust, all onto the Earth's surface. Hope you can see on the screen. Earth's surface. So, this is the definition of the fire formed rocks, and they are formed as a result of cooling. They are formed as a result of cooling, cooling, solidification, and crystallization of molten materials. Now, you have to give us the origin of volcanicity. So you tell us these rocks originate. These rocks originate from these rocks originate from volcanicity. Someone was asking me the difference between volcanicity and vulcanicity. Vulcanicity is a total process which involves extrusion of magma onto the top and intrusion of extrusion of lava onto the top of the Earth's surface and intrusion of magma into the layers of the Earth's crust. So, identify igneous rocks are fire formed rocks formed as a result of cooling, solidification, and crystallization of molten rock material, either within the Earth's crust or onto the Earth's surface. Then identify the process. These rocks originate from volcanicity. We talked about the origin. Because due to geochemical, I guess you still remember that. Geophysical reactions and radioactivity decay, which generates which generate intense heat. Intense heat, which leads to melting of rocks in the mantle into semi-molten state. Then this is followed, but we don't write big paragraphs in job 1, write small paragraphs. This is followed by generation of convective currents and due to differences in pressure, magma is intruded. Magma is either intruded or injected into the Earth's crust or extruded onto the Earth's surface. So that origin is very important. Let me repeat. You begin by describing igneous rocks are fire from the rocks. Okay, put the notes. Put the notes. Let me explain now without writing. Okay, let me put for you the notes. Though I'm very effective at writing. Okay. So if you look at that, you say igneous rocks are derived from cooling, solidification, and crystallization of molten rock material, either within the Earth's surface or so when they solidify within the Earth's surface, they solidify as lava, and when they solidify on top of the Earth's surface, they turn to inside they are still magma, outside they are called lava. So you give the origin, you identify the process which is volcanicity, and give the origin due to geochemical, geophysical reaction, and radioactivity decay within the interior. Then this was generate intense heat, and this intense heat melts the rocks in the mantle into semi-molten state. And due to differences in pressure between the Earth's interior and the Earth's crust, the material starts moving upwards in form of convective currents and is either intruded into or extruded onto the Earth's surface. Now, I want you to see this. This is the trick. I want you to see this. So now, you have to say igneous rocks can be classified. According, now emphasize this, they can be classified according to one, position of cooling, rate of cooling, and size of crystals into three we have the first classification. You have two classifications, but the first classification depends on the position of cooling, rate of cooling, and size of crystals. The second classification is about chemical composition, but we're going to first talk about this. So the second type of igneous rock, the second classification depends on the chemical composition of these rocks. But let's first look at the classification depending on the position of cooling, rate of cooling, and size of crystals. Now, we have 3 types here. The first type is called volcanic or extrusive igneous rocks. So the first type, which lie under position of cooling, rate of cooling, size of crystal, is extrusive or volcanic igneous rocks. Now, these are formed on, so these are formed,
the kitchen.
these rocks are formed.
What's your time?
Listen, these rocks are formed as a result of cooling. Are we together? Solidification and crystallization. Crystallization. So they are formed as a result, for all the 3 types, I'm going to be mentioning those words. They are formed as a result of cooling, solidification, and crystallization of lava on the Earth's surface. Earth's surface. So the position of cooling is Earth's surface. So they are formed as a result of cooling, crystallization, and solidification of molten rock onto the Earth's surface. That's the position of cooling. What about the rate of cooling? Their rate of cooling is very fast because they are exposed to gases like oxygen. What about the size of crystals? They form small crystals. Are you getting me? So, when you're talking about this, you say we have 2 classifications of for the formation of igneous rocks. The first classification is about the igneous rocks can be classified according to the rate of cooling, the rate of cooling, no, position of cooling, So they can be classified according to the rate of cooling, position of cooling, and size of crystals into 3 major types. Under that classification, the first type is extrusive. Extrusive means on Earth's surface, okay? Extrusive, all volcanic. These are formed as a result of cooling, solidification, and crystallization of molten rock material onto the Earth's surface. So you're seeing that. So they are formed when the material moves upwards and solidifies on top of the Earth's crust. Are we together? Then you have to tell us their rate of cooling. Their rate of cooling is very fast. Why? Because of low pressure and the presence of oxygen. So which type of crystals do they form? They form small crystals. Then you give us examples. You give us examples of these rocks. We have andesite, obsidian, iorite, like that. So that's the first thing. You're seeing the examples. Basalt, trachyte, pumice, rhyolite, etc. Okay? Then, when you're done with that, you got the second classification under the rate of cooling, position of cooling, and size of crystal is intrusive. So you have intrusive. They're intrusive or protonic. They're called intrusive or protonic. Scroll again. Okay, they're there. Intrusive or plutonic. They're also called abyssal. How are they formed? They are formed as a result of cooling, solidification, and crystallization of molten rock material very deep, or underground. That's why they're referred to as deep-seated. So the material moves for a short distance and solidifies very deep. What about their rate of cooling? Where do they form? Very deep. The material moves for a short distance and then solidifies very deep. What about their rate of cooling? Their rate of cooling is so slow. What about the size of crystals? They form very large crystals. Are we together? Then we go to the last type, which is called intermediate. Intermediate igneous rocks. So the intermediate ones, those ones form near the Earth's surface. They don't get out, they form when magma is about to get out. So they form magma reaches the Earth's surface. Their rate of cooling is moderate. So they form rocks with moderate crystals. So you give examples. Then when you're done, you give us the characteristics of these rocks. The characteristics of these rocks. So you say, how they are crystalline in nature, meaning they form crystals. They are usually hard, have a glassy appearance. So those are the characteristics of igneous rocks. Then after that, you look at this diagram. So if you look at that diagram, you find that the ones down are called intrusive. The ones you see before reaching the Earth's surface are called extrusive, intermediate. Then the ones you see on top of the Earth's surface are called volcanic. Then the last class question depends on the last classification is on the down. No. The last classification looks at now under classification you have acidic volcanistic. We have acidic igneous rocks. Rocks with content and basic igneous rocks, and the number is done. Let's look at another question. Let's look at another question.
I love you so much. Positional sediments of layers, stratification.
Let's look at another question, which is sedimentary rocks. You can say, write for me this question. To what extent are sedimentary rocks of organic origin? To what extent are sedimentary rocks of organic origin? To what extent are sedimentary rocks of organic origin? So when they give you that question, begin by defining sedimentary rocks or account for the formation of sedimentary rocks. To what extent are sedimentary rocks of organic origin? So you define sedimentary rocks okay. You define sedimentary rocks as sediments or remnants of other rock materials that are formed as a result of accumulation of deposited minerals and rock sediments that are worn down from the original rocks. So we have rocks which were initially gotten from other rock materials and are deposited in other areas. So there are rocks there are remnants or the sediments which are formed as a result of accumulation of deposited minerals and rock fragments worn down from the original rocks. Okay, now after that, you tell us the process for the formation of sedimentary rocks. Now you look at this slope here. Well, let me show you this slope. So the processes are like this. Can you put the light? The processes are like this. So we have that is our slope. This is our slope. Then you have layers here. So now the first process is weathering. So weathering takes place here. That's the first process. And the weathering is caused by agents of weathering. The second process is erosion. Erosion of weathered particles. So the erosion is caused by agents of erosion. Then the second process is deposition. Deposition of weathered particles. Then we have now, after deposition, you have now compression. Compression of deposited rocks. Then you have stratification. Stratification means the formation of layers. Then you have compaction. Whatever is compressed becomes compacted. Then you have cementation. Then you have consolidation. And then you have transformation. Transformation of sediments into sedimentary rocks. Transformation of sediments into sedimentary rocks. So the processes for the formation of igneous rocks are there. So the process begins with weathering of the material. The materials are weathered by the agents of weathering. Then the materials are eroded by agents of erosion. Then after erosion, they are transported. After transportation, they become deposited. But as the deposition occurs, they are deposited in layers. That's what we call stratification. Then after deposition, they become compressed. The layers, the overlying layers compress the underlying layers. Then when they are compressed, they become compacted. After becoming compacted, they become consolidated. They become more of one rock. Then finally, they become changed into, let me first look at these ones who are putting up their hands. Yes. Panyango SS, can you unmute and say something? And Omot Sid, your hands are up. Ask your question. Can you unmute and ask a question? Can I get your questions? Are we still there? Okay, so after knowing those processes, then you go to now the types. We have three types of sedimentary rocks. We have those that are organically formed. We have those that are organically formed. We have those that are chemically formed, and we have those that are, the sedimentary rocks look like that. Sedimentary rocks look like that. So they look like that. So now we have those ones which are, we have three types. You have those ones which are organically formed. Now, the organically formed sedimentary rocks, are formed from dead organic matter. Like plants die and they rot and they form those rocks. We have two things under organically formed sedimentary rocks. We have those ones which form from plants. It is said that long time ago, plants were buried underground because after being buried, layers accumulated on them. And because of too much temperatures, these plants changed into coral, C-O-A-L, coral. They call the rocks, black rocks with a lot of carbon. In fact, there are those rocks which are used for making electricity if you go to Germany. So after that, you go to the we have coral reefs. Those are from animals. Corals die and they drop on the continental shelf where they accumulate. And after accumulating, they form coral reefs. And those coral reefs is what we call organically formed sedimentary rocks, but by animals. Then when you're done with that, you go to now the chemically formed. The chemically formed come from areas experiencing very hot environments. And these areas experience high rates of evaporation, where minerals are evaporated from underground and they come on top of the Earth's surface. When they come on top of the Earth's surface, then they form those chemically formed sedimentary rocks. So after that, the examples we have is rock salt. I don't know who has ever gone to Lake Katwe? Who has ever gone to Lake Katwe? On Lake Katwe, there is a lake. Under that lake, we have salt. So when the temperatures go high, salt evaporates and fills up that lake, and then the salt is removed. So you have evaporation and precipitation of minerals. Then lastly, we have those ones that are mechanically formed. The mechanically formed sedimentary rocks result from agents of erosion, which cause erosion. These agents cause erosion. These agents cause erosion. These agents cause erosion. These agents cause erosion, transportation, deposition, and the materials hardened from rocks. For example, where you have wind depositing materials and the materials harden into rocks, it is the formation of what we call loess. Where you have rivers depositing material, it is the formation of so where you have wind depositing, have the formation of loess. Where we have river, we have the formation of alluvial. Where you have glacier, erosion and deposition, you have the formation of moraine. So now here we emphasize the agents of erosion. So basically, let me summarize the question. Define sedimentary rocks. Give the characteristics of sedimentary rocks. Define sedimentary rocks. Give the characteristics of define sedimentary rocks. Give the characteristics of sedimentary rocks. After giving the characteristics of sedimentary rocks, then give the processes: weathering, erosion, transportation, deposition, stratification, those ones. Then when you're done, give us the three types: the organically formed, the chemically explain them, illustrate them, give examples, and the question is done. Let's go to another question. Another question is there. Examine the influence of faulting on drainage. Examine the influence of faulting on drainage. So examine the influence of faulting on drainage. Examine the influence of faulting on drainage. So if you're given that, if you're given that kind of question, of course you define faulting. You define faulting. That's the approach. Then you give the origin of faulting. Then you identify areas in East Africa where faulting has taken place. So you define faulting. After defining faulting, you give the origin of faulting, identify the areas where faulting takes place. Then, when you're done with that, you go to the influence of faulting on drainage. So, of course, when you're defining faulting, make sure you include two things. You include faulting as the disintegration, breaking, cracking of rocks, as well as their displacement along the same line of weakness. That it refers to the breaking, cracking, disintegration, fracturing of rocks, as well as their displacement along the same line of weakness. So when you're done with that, you go to the origin of faulting. Now, the origin of faulting is somehow similar to the origin of volcanicity. We talk about the geochemical, geophysical reactions, and radioactivity decay. Are we together? Geophysical, geochemical reactions, as well as radioactivity decay, which lead to the melting of rocks in the mantle into a mountainy state. This is followed by generation of convective currents, which either diverge to create tensional forces, or converge to create tensional forces, or no, they diverge to create tensional forces, they converge to create compressional forces, they rise to create differential uplift, or they sink to create relative sinking. They rise to create differential uplift, they sink to create relative sinking, they diverge to create tensional forces, or they converge to create compressional forces. Then you tell us areas in East Africa that are experiencing faulting. Of course, you know where you have the arms of Rift Valley, where you have Block Mountains, that is Rwenzori, etc. Now, after that, go to the influence of faulting on drainage. Now, drainage, we don't talk about relief features. We talk about drainage features only. The first one is faulting leads to the formation of a waterfall. That's the first drainage feature. How you describe a waterfall? A waterfall is a drainage feature where water falls from a high elevation to a low elevation. How is it formed? It is formed by vertical faulting. Vertical faulting across a river valley or a river profile. So I have a faulting taking place on a flow of a river. One part will go down and another will remain up. And that will be a waterfall. Then you give us examples of waterfalls. So that's the first answer. The second answer is faulting is the formation of fault-guided valley. How? This is due to horizontal or tear faulting. If a river is flowing in a valley, Then horizontal faulting takes place. I'm going to demonstrate them on the board. So horizontal faulting, or the first one, vertical faulting. Vertical faulting is where you have. Vertical faulting is where you have. Vertical faulting is where you have, like for example, this is, now the river is flowing on top of this. Then all of a sudden faulting occurs, and this place goes down. And this one goes up, so we shall have this kind of thing. Now this river which was flowing like this will be forced to, so this is what we call vertical faulting. Then tier faulting, the second one, which is formation of fault guided by like river Atwa or river Aswa. For us here, we call it Aswa. And here, there in Ilangi, Langi, no, I think actually, who greets Etienne or Etienne or Nedi, they call it river Atwa. So you have this block of land, the river is flowing this side like this. Then all of a sudden faulting occurs. When faulting occurs, this block goes this side and this block goes this side. So we shall have this kind of thing. No, before this, that's right. Before this, we have this block of land. You have that block of land like that. Then there is a river flowing here. The faulting occurs and creates this crack. Then the river comes and carves out a valley out of this crack. So the river follows the valley that was created out of the crack created by faulting. So that's that. Then we go to another one. Faulting leads to drainage reversal. Faulting leads to drainage reversal. Drainage reversal. So how did this happen? It is said that the whole of Uganda was said to be flat. Let's say this is our Uganda. It was said that long time ago, the whole of Uganda was flat, and you had rivers which are flowing westwards. These rivers are flowing westwards into, they are flowing westwards into Congo. Now what happened? We had the formation of a Rift Valley. We had the formation of Rift Valley in eastern Uganda. And this Rift Valley was formed as a result of compression. So the shoulders rose. When the shoulders rose, there was a formation of a Rift Valley in central Kenya, and the shoulders of Rift Valley rose. So now, after the Rift Valley rising, it was like this. It was like this. That was our block. So we had the formation of Rift Valley and the sides rose. Then you have also a formation of Rift Valley in central Kenya and the sides rose. Of course, these sides rose to form Rwenzori Mountain. Now the rivers which were flowing this side, that was Katonga, Protokagera, forced to reverse their flow and fill up the depression occupied by Lake Victoria and Lake Kyoga. That is drainage reversal. So faulting led to reversal of drainage of rivers like Protokatonga, Protokagera to form the lakes we have. Then faulting led to the formation of radial drainage pattern. Now, radial drainage pattern is where you have faulting leading to the formation of Mount Rwenzori. You know how Mount Rwenzori was formed? You explain? Then, because of ice on Mount Rwenzori, you have rivers originating from the top of Mount Rwenzori, and they flow in different directions. So that's radial drainage pattern. So you have faulting is leading to the formation of Mount Rwenzori. Then rivers originate from this, and they flow in different directions. This kind of drainage pattern is what called radial drainage pattern. And the rivers we have Nyamwamba, River Mumbuku, etc. Then you have the formation of Rift Valley Lake. Of course, we had the formation of the main Rift Valley, and you have to illustrate. I didn't draw illustrations, I didn't have time. So faulting led to the formation of graben lakes or Rift Valley lakes. How are they formed? They were formed as a result of of course, we had the formation of the main Rift Valley. Then secondary faulting took place on the floor of the Rift Valley to create small depressions, which were later filled by water from rain and from rivers, form lakes. For example, we have Lake Naivasha, Lake Choga, Lake Albert, etc., etc., etc. Then you have to illustrate. Somebody is asking about rocks. You have to illustrate at all costs. Then we go to formation of tilt blocks. Tilt blocks are those angular ridges which occur on top of block mountains. You have a mountain like this. It is kind of bent like that. So they form those ones. So these are now, when they're occupied by lakes, they form tilt block lakes. So faulting is the formation of tilt block lakes. So here we don't talk about landforms, we talk about features. Then I don't know whether I said about types of drainage, but there's what we call unascended drainage pattern. An unascended drainage pattern is where a river, there was a river flowing, then what happens? Land is uplifted upwards as a result of faulting. But as it is being uplifted, the river continues to dig downwards. The river continues to dig downwards. So an unascended drainage pattern is that drainage pattern where the river is able to erode and maintain its movement or its course as uplifting is taking place. So the river digs through the land that is uplifted. So that's what we call unascended drainage patterns. Then we have river capture. So a river capture can take place as a result of faulting. I think they told you what they mean by river capture. You have two rivers flowing in the same direction. Then if one land is uplifted and another remains down, chances are high that the river, which is on a higher elevation, will be forced to flow and joins the other river, which is at a lower elevation. Then faulting can also lead to river rejuvenation. Faulting can also lead to river rejuvenation. Now, river rejuvenation is where you have a river which was flowing at a slow pace, all of a sudden starting to flow very fast. This can happen, for example, you have a river flowing like this at a very slow pace. Then all of a sudden, faulting takes place and this part goes down. Now this river which was moving at a slow pace, because of this bending, it will start flowing very fast. That's what we call river rejuvenation. Then faulting leads to trellis drainage pattern. Now trellis drainage pattern is that kind of pattern where rivers, you have land, but this land breaks into this. Then when the river comes, it develops tributaries joining at right angles. So you have a river with the tributaries joining at right angles. But what causes this is faulting. That's trellis drainage pattern. So don't move away. We're going to do some questions on soil, which are very easy to do. Some people are sending messages. They are hungry, but I don't know what you're going to do. I'm going to do some questions which are very easy to do in section C. In fact, now let me leave section B. I'll talk about weathering by Sims. So let's go to section C. The good thing you see You go to, so we said, okay, I'm starting. So we're saying that weathering, you define weathering as the physical disintegration, the physical breakdown of rocks from big particles, small particles. Then you also talk about chemical decomposition. And you mentioned that as the first process in the formation of soil and soil profile. So you say where we have high rates of weathering, you have the formation of deep mature soil. Where you have low rates of weathering, you have the formation of shallow immature soil. Then you go to the next process. The next process is leaching. Now, leaching, you tell us the movement or the removal of whatever can dissolve in water, soluble nutrients, from the upper layers to the lower layers. So you tell us its effect. You tell us its effect. We're still continuing, two more numbers and we call it a day. So you tell us its effect. It is the formation of a light color zone in a horizon. Then you go to eluviation. Eluviation is like leaching. Eluviation is like leaching. Now leaching is the removal from upper layers, downer layers of soluble materials. Then eluviation is the removal of solid soil particles or soily particles from the upper layer to down layer, either vertically or horizontally. Its effect, it leads to light color zone. Then we go to eluviation. Eluviation, whatever moves from A horizon settles in B horizon. So it is the accumulation and precipitation of leached and eluviated materials from A to B. So whatever is moved by eluviation and leaching is what we call eluviation. Then we go to humidification. Humidification is the easiest. The organic matter decays to form humus, and it is responsible for the formation of dark layer in A horizon. Then you go to, I'm summarizing, you read. Then you go to mineralization. Now, mineralization is somehow similar to humidification, but this one occurs under extreme conditions, where organic matter, instead of decaying, it goes beyond decaying and it is converted to organic, it is converted to basic minerals like silica. So the leaves, the what, are broken down into minerals. That process is called mineralization. Then you have lateralization. Now, lateralization is where you have a mineral containing three components. It contains silica, aluminium, and iron. Now, when it rains, silica goes down, iron and aluminium hardens to form what we call laterites. So that's lateralization. Scroll. Then we have what we call calcification. Now, these two, I'm going to talk about them. These two are kind of similar but different. No, you can't put it down. So these two, now we have calcification. And we have salination. This one comes from calcium. This one comes from calcium. This one comes from salt. Now, it happens in desert areas where you have, when it rains, rainwater enters the soil and dissolves the minerals that are there. Sometimes it can dissolve calcium, sometimes it can dissolve salt. Now, when the temperatures go high, this mineral evaporates upwards. Now, when it evaporates upwards with water, that's what we call by capillary action. When it evaporates, it solidifies on top of the Earth's surface and forms now the soil. So if it is the salt evaporating upward, that is salination. If it is calcium evaporating upward, that is calcification. Hope it is okay. Now we go to another one. So we have glaciation. Now glaciation happens where you have flooding. flooding, and flooding leads to partial decomposition of organic matter and leads to the formation of clay soil. Let's look at the last lesson. It seems you're tired. What's the time? 6. Okay, let's look at the last question, and I leave you. We shall meet, and you get your questions, and we'll call it a day. Oh, it's not there. Okay, the last question is about. Let me just open the screen. Now, there's things which are easy to do. There are things which are easy to do. I'll put the whole screen. There are things which are easy to do. There are things which are easy to do, but you fear them. For example, when we go to climatology, there are those numbers of rainfall, factors influencing rainfall. Let's share this. Now, these numbers, they can say, distinguish between convection rainfall and the relief rainfall, explain the factors influencing the formation of rainfall. Once you know the factors of climate, you can do rainfall. And the same factors of rainfall are the same factors for humidity. Then there's a number which says distinguish between, distinguish between temperature inversion, and the temperature inversion and the lapse rate. Temperature inversion is where I have the higher you go, the cooler it becomes. Lapse rate is where I have. So the causes of temperature inversion, we shall see them. Maybe you can ask your questions and we call it a day. Unmute and ask questions. Unmute and ask questions. Can you unmute and ask questions? Yes, blood future. Maybe speak. Okay, ask questions, unmute and ask questions. I want to know your questions and I leave you to rest. So unmute. Unmute and ask questions, people. Ask whatever question you want. Okay, sure. Ask your questions, please. Missy. Okay, come and allow them to unmute. Allow them to unmute. Let's click here and I like look. I think we can do it at once. Okay. Okay, unmute now. I want to hear from you. Ask your questions. I've allowed you to unmute. Ask different questions. Yes. Ask questions.
Right Future Academy. Describe, explain the formation of lateritic soil.
Lateritic soils. So you can say account for the formation of lateral soils. Now, when they ask that question, you begin by defining lateritic soils. Are we together? Then you give the characteristics of lateritic soils. Now you give factors. Now under those factors, you have heavy rainfall, which facilitates deep. We have heavy rainfall, which facilitates leaching. You have very hot temperatures. Then you have presence of mountain tops, which allow. So I'm going to share that on this. Then when you're done, you give us the processes for the formation of lateritic soils. You have weathering, you have deep chemical weathering, you have carbonation. I'm going to share that file for you. It is within the what I've compiled for you. So don't worry, you see that file there. So it's a very big thing. It will be like I'm teaching, but I shared it. Another question?
Yes, sir.
Yes.
Since we have discussed many questions on paper 1, are we also going to have paper and
Paper 2 shall get another teacher.
This is enough?
Shall get another teacher for next time. Ask another question on job 1 strictly.
Mike, where's the microphone?
Yes.
Future, eh? Bright Future Academy. To what extent does the nature of materials ejected influence the formation of volcanic relief landforms?
That's very easy. Now that one is about volcanicity. So you first identify the nature ejected. Are we together? You define the nature ejected, which process ejects that thing that is volcanicity. Are we together? Extrusive volcanicity. What is extrusive volcanicity? Define the various nature. We have different natures. We have lava, we have solid particles. Now, but we're interested in the lava. We have the basic lava, the acidic lava. When you're explaining that, you try to relate the landforms to the, for example, when you're explaining the formation of a basalt dome, you say a basalt dome is formed through silent eruption of lava, which is able to flow for a long distance before solidifying. So you identify the type of lava, which is a basic forming basalt dome. A cumulo dome is formed through violent eruption of acidic lava. Are we together? Ash and cinder cones are formed through a violent eruption of, so you mention a material, you try to relate the material to the formation of features. In other words, you're talking about volcanicity, but make sure for every landform you mention the material that's involved. Is it basic? Is it? Hope I've answered your question. Another question?
Thank you.
Welcome. Another question? Yes, bright future.
After this one, then.
Yes.
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 I
cannot hear you. St. Andrews?
From the photograph where we're having the stalagmites and the stalactites, we were seeing something like fire yellow from inside, and really we said it is formed as a due to the rocks.
That is limestone. That is limestone.
So it was limestone.
That is limestone, and it forms those different features, which we call the stalagmites and stalactites. It is, that topic is.
Okay.
But to explain how carbonation, the process of carbonation. Carbonation, it rains with carbonic acid. It rains, rainwater gets into contact with the carbon dioxide of the atmosphere to form a weak carbonic acid, which dissolves calcium to form those features. Another question?
Another one is, we did not understand well on the Tower index.
On what?
The Tower index.
On what?
The tower index.
The tower index.
Send a message. I'm not getting you.
I am saying we had the proofreading that was very different. But on the part of the tower index, we did not understand it well.
You send on my WhatsApp. I'm not getting you.
Okay, but now your number of WhatsApp.
Okay, we shall meet next time and answer those questions.
Okay, sir.
Have a nice time.
Nice time to you.
My WhatsApp number is there. You can ask questions.
Bokodo. What is a pick us though?
St. Andrews, they picked St. Andrews, they're not asking.
Yes, only pick.
He's waiting with St. Andrews. They've not yet picked us. St. Andrews already.
So yeah.
Okay, bright future.
Yes, sir.
Bright future. I have a question on vegetation, but it states they have
Maybe the problem
for
is the map.
distribution of savanna
Maybe
vegetation,
the
but
is not there.
savanna they are divided into three. Yeah,
Asking the question.
Honestly, I can laugh. And the year in Zero.
about the conditions which favor savanna woodland and grassland are different from that of dry savanna. So what if they ask